you might probably have to say, yes, I consent to the recording, etc. And thank you for consenting. Right, so what we need to do today is to create a vegetation map starting from the raw data. Now, the short field sessions that we used to have in February and in March were all leading up to this. They are field sessions in which you can recognize plants, in which you can count plants, in which you can recognize communities or phytocoenoses, etc. And in theory, we should have done this last Tuesday in Gozo, except it was too hot to do that last Tuesday. So as we explained on Tuesday, before we all rushed off to air-conditioned cars, mine wasn't, by the way, as I think Shania and what's her face, Michelle, noticed. Just before we stopped, I told you I'd give you the species list myself. So we'll start off from here. In theory, this would have been done together as a class, going over the different areas of Dweira and taking species lists using the methods that we had explained in February and in March. Are you okay with that, please? Now, you will also remember that in February and March, or whenever, you also had a session about QGIS with Arthur Lamoliere. I hope you still have the materials from that session, because you'll be needing that to draw a map. You can, of course, draw a map using Google Earth, as I'll show you today, but you won't have learned much. So given that GIS will be an essential tool for many of you later on in life, perhaps even now in life, in your dissertations, then it would be great if you could brush up on that. You've got a very good tutorial that you were given, and use that. By the way, I wanted to ask you a favor. During Arthur's tutorial, you were asked to download a data set. Do you remember that? Does anyone have that data set? Because I lost mine. If anyone still has that data set, perhaps if you could send it to me, that would be great, because I wanted to use it for something else. Unfortunately, I
might still have it. Let me check.
Yes, please, Neve. Thank you so much. Thanks. If you have it, Neve, that would be great. If you could send it to me in your own time, that would be great. So the place that we're going to start off from here today is this. We're assuming that last Tuesday it wasn't a temperature of 1,000,000 degrees in Dweira, but it was a temperature that was cool enough to allow us to do field work reasonably. And we all went around Dweira and collected a species list. Now, I'm going to share my screen. And I'm going to show you what I mean. So could you tell me what you're seeing, please? Over here. On your own screens, please. Could someone just speak up, because I can't see what you're seeing?
We're just seeing the folders.
Okay, all right. And you can see my browser over here, all right? Including that Crystal has joined your meeting. You were the first one to join in. So that goes. Oh, yeah. By the way, the feedback on evolution. We've got 10 replies so far. Please feel guilty and give in your replies, because I need a bit more. I've got to give these to the external examiner by the end of the week. So 10 replies is not bad, but it could be far, far better. And this is what Julia was trying to advertise to all of you. So Julia, okay, you got your moment over here, free of charge advertising for your own language. Apparently you were designed for high performance. You are dynamically typed, and you use multiple dispatch as a paradigm. That's great. Your parents never knew that, I think, especially that you were an open source project. That gives all sorts of wrong messages. Anyway, So that was just, sorry, Julia, but I never thought you were an open source project. I just thought you were a private one. Now, anyway, what we're going to start off from here is this. Now, I've prepared the data file. This is real data, by the way, accumulated over a 30-year period between 1984 and 2014 of plants in Dweira. And if I click on it, this is what you'll see. I'll be making this file available to you. Now, this data has been entered in what is known as clean format or tidy format. Tidy format is a way of entering data which is useful for programs like R, etc., that use data that has to be well structured. And the way that this works is the following. So I'll just sort this out. To bring it back to the way that I wanted it to. So sort and filter, custom sort, and sort by relevant. So you might remember that last November, last February and March, we had explained what a releve is. It is an area that is usually standard 5 meters by 5 meters. The usual recommendation is 24 meters squared, but we take 25 because it's much more straightforward to get 5 by 5 meters. And a releve is simply a sample point in which we're looking at plant species. Each plant species is described in terms of its abundance. It's a categorical scale. It goes from 1 to 5. You know, if you've got something like 80%, then that's 5. If you've got something like 20%, it's 1. If you've got less than that, it's 0.5. So these are categories more than anything. And therefore, we start off. So instead of using this format, which is sometimes messy, where we've got the releve number and then the species name, etc., instead of having a huge species by site matrix, site by species matrix, we do it this way because it's easier to enter data. So we start off with releve 1. We had Limbarda and Hyoceris, both of those are species. They're in releve 1. Their abundances were 0.5 and 1. Releve 1 was in site A. Now, what's site A? You will remember that when we were in Gozo, we had to split ourselves into 3 parts of Dweira, site A, site B, site C, and there's also site D. And we had to go around there taking species lists, which we didn't because it was too hot. So releve 1 is in site A. Releve 2 has Limbarda and Hyoceris again, abundances of 0.5, and once again it's in site A, and this also has Symphothrecum. Releve 3 has 3 species, Limbarda, Symphothrecum, and Hypericum. Releve 4 has 1 species, Limbarda. Releve 5, 2 species. Releve 6 has many more species, it has 10. Releve 7 has many more species, and so on and so forth. Notice that releve 6 starts from, sorry, releve 7 is inside B. These are my mistakes, I'm sorry. So, sorry, my mistakes, because I had changed everything around. So we've got these releves up to releve 8, which are in site B, relevant 9, 10, 11, 12, 13, 14, up to 20 are in site C. And there's one lonely releve in site D, which is a bit of an outlier. So we've got these species over here in these sites with these abundances. Now, up to this point, does anyone have any queries about what this data set means? It is organized in what is known as tidy format. Is that clear, please? Okay, so each observation, that is, each species, has its own line. In our usual traditional case, we would have, you know, one line for one species, Limbard, and then how much there is in releve 1 and how much there is in releve 2, how much there is in releve 3, which is easier to understand, but much more messy to build up. Because you know, if you come across Symfio in releve 2 and releve 3, and then don't come across it again, then you might forget to put in the zeros, etc. So in this case, we've got this situation over here. Entering data is far easier using tidy format. Is this understood, please, all of you? Flora, are we okay with that, please? Because I can't see your expression over there.
Yes, all good.
Right, thank you. Thank you, all of you. Neve, is that okay as well?
Yes, Prof.
All right. Neve, I'm assuming your camera doesn't work, either that, or you've got a close-up of a black t-shirt with your name on it.
Close up. No, no, I didn't manage to switch it on because I have a problem with my Wi-Fi. And so it's glitching.
Okay, don't worry. We'd rather see you glitching than not see you at all.
Sorry about that. No, as
Sure.
in my the program is glitching when I switch it on.
Oh, don't worry, don't worry. I mean, we've always wanted to see you glitching, but Neve, if it's going to create problems, don't worry about that. We know what you look like. We just wanted to
Sorry
check.
about that. No, I won't see anything new.
Not an imposter trying to sneak into the tutorial.
No, it's just me.
Anyway, so that is how it works. Now, this, okay, Julia's already yawning. It must be getting boring. So this, she can't even yawn in peace and show Kia now, let alone at uni. Now, this data set, therefore, this type of data is great for data entry, but not intuitive for analysis. So what we now have to do is to convert it into a form where you've got the site, like releve 1 in each row, so under each other, releve 1, releve 2, releve 3, and then the columns, the species, Lombarda, Hyoceres, etc. That might sound simple, but you're going to find out that it's not after a while, because each time you get new species. So we've got two options. We can either do this manually, which will take ages, or else we can use our new best friend to do it for us. And over the past 12 months, I think you've realized who your new best friend is. And yeah, it's ChatGPT. So I'm going to use ChatGPT to organize this data for us. What I need to do first is this. Look carefully. This file is saved in Excel format, XLSX. I'm now going to save it in a format that any program on Earth can understand, the simplest file format that has been around since 1980 or before. It's CSV, comma, separated variable. So you go and save a copy. Here, where there's the file type, I look for CSV, comma, delimited, and click on that. And then I'll save it as that. So it's Dweira 2024 for analysis, and it's saved. And that would be my program over there, my file over here. I'm going to open that now in a notepad, which makes it simpler. This is it. And this is what the format is. It has nothing of the formatting that Excel would have. It's just got raw numbers and text and commas. So species, Lombarda, releve 1, abundance 0.5, site A. Now, we now have to convert this tidy format into a format that can be more intuitive and that can be analyzed. I'm going to use ChatGPT for that. And it's still on 10. If some of you could possibly do it later on today, that would be great. I'm using ChatGPT version 4 Omni. The monthly subscription is the cost of a couple of shots. So instead of getting stoned, you just subscribe to it for a month. Clint, fil-festa aktar xar darbit iktar fuq xorb jew modelli żgħar tal-Madonna tax-Xewkija jew xi ħaġa. So it's worth having. And I've already prepared a prompt. Remember, the prompts are key for ChatGPT. Prompt engineering is the new literacy. I'm going to upload the data file, which I've just created in CSV format. I'm going to press enter, so that gives ChatGPT a few seconds to get familiar with the format, even to make sure that it's imported correctly, etc. And it's now telling me what my data looks like. So that's great. And I'm going to enter this prompt. Now, I'm not making up the prompt now because I tried this before. And the prompt works. It's a standard one which I use for this sort of transformation. So it says this. Can you rearrange the data set in this way? Please. So use the data in it to create a releve species matrix. So releve in the columns, releve in the rows, species in the matrix. The 21 releves should be in separate rows, and the species names should be in the columns. The abundances are to be in the cells of the table. When a species is absent from a releve, then fill in its value with a 0, a numerical 0. You've got to specify everything, because otherwise it might simply write the ZERO or something. Remember, we're talking to a machine. So I'm clicking enter and hoping for the best. It's now using Python to try and make our wish come true. And it's rearranged the data in a way that seems good. So we've got releves 1, 2, 3, 4, and we've got the species, allium, that's allium commutatum, allium melitense, apium nodiflorum, etc. You can see Lombardas in releve 1, and there was also Hyoceris in releve 1, so it should be here, exactly, and so on. But to be able to use this data, I need to download it. So I can ask nicely, could I download this file, please? And it's now going to create a link to allow us to download this file. So I'm clicking on the link. I'm starting the download. And I'm getting it from my downloads folder into the dataset over here, where it's called Releve Species Matrix. Now, I'm going to give it a more intuitive name, a name that I can perhaps understand. So let's call it, I don't know, Dweira 1. I'm calling it Dweira 1 because there might be the possibility of having another file called Dweira 2 or something later on. So Dweira 1. And that's it. That is the file that we'll be using. What does it look like? So we've got, yeah, let's open it in something else. Let's open it in Excel because it looks neater. So this is it. The relevant species matrix. Now you could argue, why didn't we do our data in this way straight away, straight from data entry? Because with each new relevant, we have to add new species. So we're going to have to go back to the previous relevants, add zeros where they weren't, and things like that. Is this understood, please, all of you? Are you okay, please? All right, great. So this is a way of using ChatGPT to actually do our data for us. Is that okay, please? Now, I realize that not all of you might have ChatGPT beyond the free version, but if you don't, then this data file will still be available to you. I'm going to give it to you. But I'd also like you to try and create it on your own, because that gives you some practice in using the prompts in ChatGPT. Is that understood, please? Okay, good. So we now have the data file that we're going to examine. I'm now going to Google Earth. I'm now going to Google Earth, and I'm going to zoom in on Dweira. And these are the 3 areas that we had. I'll just go back to the data file. So area C, area B, area A. Okay, so just rename these. Area 1 is actually side B. Area 2 is site C. Area 3 is site A. And I'm adding a new area, which is over here, very small, which we call site D. Let's give it a color. I don't know. Diana, what's your favorite color, please? Is it pink?
Yeah, blue.
Okay, pink or blue? Okay, blue. So, and we give it some transparency so we can see through that color as well. Great. So we've got these 4 colors over here. Hang on. I'm making one of the areas red so that Clint and Julia will feel at home, because the colors of the Shawqiyya flag are red and yellow, I think, aren't they? Great, much like Spain. So you know, Spain got their colors from Shawqiyya. Now, so this is what we have over here. 4 sites, which are site A, site B, and over here site D. So let's rename that. So from each of these sites, we've got a few relevés. In total, we've got 21 relevés. And it's not symmetrical. It's not like we've got 5 relevés from each site. You might get many of them from one site and a few of them from one site. Site D, for instance, only has 1 relevé. And site A, I think, only has a couple. So that is just to keep in mind where we are. Now, these are sites, they're not plant communities. They're just areas where we got data from. Now, you might argue, why didn't we get data from the whole place? We didn't get data from the whole place because we never do that. You'd need too much time. So we subsample. So we got some relevance from that area, some relevance from that area, some from that, and one from that. We're not getting the whole picture, but then we never can get the whole picture. That's why there's a whole science and a whole rationale behind sampling theory, because we can never get the whole thing. So let's zoom out a bit. Just say hello to our friends over here. So that's great. Okay. So we know that it's still there, at least on the map. It hasn't been nuked. And that is where we'll be working. Now, we're now going to analyze the data that we have. But I wanted to show you where the data came from, so you'll know that it came from different areas. Now, so what shall we use for analysis? Had we ever used this program? It's called Orange. We had, all right. I'm going to try and get us to use Orange even more over the next 12 months. I mean, even next year in plant systematics, you'll need to use it to classify species with. And today, quite appropriately, we're going to use an orange to carry out our vegetation analysis. So, Floor, you must be feeling really at home here because orange is the national color of Holland, isn't it?
Yeah, it is, but I don't really associate myself that strongly with it, so.
Yeah, don't worry, but yeah, I'm just, apparently it comes from William of Orange or something.
Yeah.
All right. Anyway, William of Orange was a king, by the way. He wasn't somebody who sold oranges. Now, so let's start off from here. Now, if you're not yet very familiar with Orange, don't worry. Just follow the steps and then go through them. Orange has a number of widgets over here, which you can see. Some of them are concerned with data, others with transformation of data, others with visualizing data, and so on. And yeah, you can keep on opening these whenever you wish. And the first one we're going to use is this one, CSV file import. Now, we've seen CSV before, haven't we? Because we converted our data file to CSV. So our first widget, a widget is an icon, a picture, which actually hides some code. So you choose the picture instead of writing the code yourself. I'm going to click on the CSV file import, double click. It's going to ask me for the file that I want to use. It doesn't actually ask me, but you know, you've got to figure it out. I'm browsing the file system, going to datasets where I've stored my file, and I'm going to dweira1.csv. Dweira1 is the file that we used. And here you can see our file. You've got the relevant number, you've got the species, etc. Notice that we don't have the site, because when we transformed the data, we only specified that we should have the relevant number, the species, and the abundances, ignoring the sites. Is that clear, please? So in this transformed data file, the site is not there. Now, so we know we've got the right file. It's got 21 rows corresponding to 21 releves, 26 features, which are the 26 species. There's no metadata that we put in, so you know it's like that. Now, what do we need to do with this? Well, during one of our tutorials, we had looked at a technique called cluster analysis. Do you remember doing that, please? I'm not asking you how to work it out. Do you remember doing that? You do.
Yes,
Cluster
yeah.
analysis, thank you. Cluster analysis is a type of multivariate analysis. Multivariate means dealing with many variables at once, in this case, 26 variables, 26 species, and trying to summarize all that information into one graph, one diagram, one result. And the first step that we need to take is to see how different each releve is from each other in terms of their species and their abundances. And if we go through the list of widgets over here, we're going to find one called distance. So I'm going to click on that once. Distance allows us to create a matrix showing us how different each releve is from every other releve. We need to connect the file with the widget, which it's not doing for some reason. Yeah, but because I chose distance, right? That's done. Sorry, I need to choose distances. So I've got to connect this to that. So the data in the file now travels along that pipe to the distance calculator. If we click on distance, we get our choices. We're comparing rows with each other. We're comparing the releves. And here we've got the different types of distance metric. Now, in this case, because we have the abundances, then we can actually calculate the Euclidean distance, which works with abundances. The Accard coefficient works with presence absence data, so we can use it here as well, but there's almost no point because we've got the abundances. It would be a shame to lose those. The cosine distance is used when comparing text, mainly groups of text, and that's what I had used to create that anti-plagiarism routine I had written last year for your class. In our case, we can use Euclidean distance. The difference between normalized and not normalized is that if the abundances were in different units, then we'll have to normalize them all so that they're comparable. You can imagine a situation in which we're looking at water quality. One column has salinity, the other has pH, the other has turbidity. So pH is from 1 to 14. Conductivity goes from 0 to several hundreds of thousands. So not to get different units with their different scales dominating each other, then we normalize that. In this case, we don't need to. And then you've got some others which are useful for other purposes. We're using Euclidean. It's a good all-purpose distance. And that is it. Now, so far, remember, this is a computer program. All we've asked Orange to do is to import that data and calculate how different each releve is from every other releve. But we haven't yet asked it to show us the results. When you're speaking to a person and you say, could you calculate that? The unwritten assumption is, implication is, could you calculate that and show me the result? Here you've got to specify everything. So we've got to display the distance matrix. And by doing that, we get a distance matrix over here. So you can see that releve 1 is more similar to releve 2 than it is to releve 3, for instance. It's very different from releve 21, for the sake of argument, etc. But in itself, although this is our result, that result is very difficult to interpret intuitively just by looking at it. It won't do. So, in a sense, we now need to find a way of presenting this in a graphical format. And the way to present that distance matrix in a graphical format is by using cluster analysis, a tree diagram, a dendrogram. They mean the same thing. And here we've got a couple of ways of doing that. We've got a widget which is called hierarchical clustering. I'm clicking on that. And getting the data from the distance matrix into that. Remember, the distance matrix here is just the viewer. So you're just getting the results from that and showing them in a matrix. Here, you're getting the results from that, piping them into cluster analysis. You can do it in other ways. You can get a heat map, for instance. So a distance map could give you this. And you can see, using a heat map, just which is closer to each other. So you've got darker colors are closer, lighter colors are more dissimilar. You can use any sort of color palette that you want. Anyway, and modify. Oh, wow. All right, I've never tried that. So this actually gives you the dendrogram as well. You can play about with orange and get a lemon. Now, let's look at the hierarchical clustering. This gives us a very neat result over here. Now, this is why orange is so good. It hasn't only calculated the cluster analysis, it's also suggested the best clusters for you. Can you see that, please? So, we've got one cluster here. We've got one cluster here that contains releves 1, 2, 3, 4, 5. That makes sense. They were taken from the same place. 6, 7, and 8 are together in a different cluster. 9, 10, 14, 13, 11, and 12 are their own cluster. 21 is its own cluster. That was site D. 15, 16, 20, 19, 17, 18, their own cluster too. Now, however, that subdivision of clusters is arbitrary. This is where your skill and where your decision and your discretion as a biologist comes in, because you can drag this line and have 2 clusters, which might actually also make sense. So you've got 2 plant communities in Dweira, releves 1 to 8 and then releves 9 to 21. Or else you might decide that it makes more sense that what you see matches this, 3 communities. So there is no correct answer. Do you understand that? There is no correct answer. It is up to you to choose a classification and to justify that classification based on what you see in real life. Are we okay with that, please? Now, at this point, does anyone have any queries? Okay, a simple no would be enough because I'm trying to see your...
No, it's okay.
Okay. No, it's okay. Thanks. Okay, great. So the suggestion that Orange came up with was 4 clusters, but you might figure out that a 3 cluster solution or a 2 cluster solution matches real life even better. Remember, don't let a machine make up your mind for you. Remember something else. Cluster analysis gives you clusters even when they don't exist. So you've got to look at the makeup of those clusters to see whether it actually makes biological and ecological sense. Is that clear, please? Okay. Now, When we're carrying out classifications like these, there's also something else to keep in mind. Never, ever rely on one method only, because every single method of analysis has its own bias, and every single method will give you slightly different results. It's like asking you, what did you think of the evolution exam? I might ask Katya and get one opinion, but I can't assume that Katya's opinion is the opinion, because I might ask Crystal and get a different one. I might ask Clint and say it Festa or something like that. So that is what we've got to keep in mind, please. Okay. So I'm going to use one or two more methods of multivariate analysis. And one of them is called PCA, Principal Component Analysis. Now, the difference between cluster analysis, which we've got here as hierarchical clustering, and PCA is that clustering is a classification algorithm. It gives you classes. You've got 1 class, 2 class, 3 class. Can you see class 1, class 2, class 3? PCA, on the other hand, is an ordination. It puts things in some sort of order, but stops short of telling you you've got that cluster and that cluster and that cluster. That is up to you to make your mind up with. Let's see whether this works in this way. So, okay, this comes directly from the data, I think. All right. The PCA has been worked out, but all we see here is the internal working. We don't see something useful. So we've got to add a scatter plot. Where's scatter plot? Somewhere here. That will be in visualize. So scatter plot is here to see the result. And this is what we get, which still doesn't mean much anyway. So let's see whether the relevance tell us something. Okay, it tells us something. These are the different relevés. Can you see that? So this is, yeah, each different color is a different relevé. And it's organizing them into groups. So you can see that there is some sort of order over here. Let's close that. We could also do it another way. If I try to connect this to that, let's see if we get something. No, we don't. That's rubbish. We could actually try clustering the results of the hierarchical analysis into this. And no, it doesn't work. All right, we're simply getting 3 epicenters for each one. No, that won't work. Axis 1 is, it should be PC1. Axis 2 is PC2. Yeah, and the dividing part is the cluster. So let's see, shape, no size, no label. Okay, yeah, show color regions. So like this, we're actually now seeing the different clusters, because cluster analysis simply classifies things. When you look at them in slightly more detail, you might see that, okay, this is cluster 1. But even though they're all in cluster 1, they're not all so close. This is cluster 2, but you know, there's a bit of a gap. Cluster 3 seems okay. Cluster 4 is nowhere to be seen, because it's very, very small, or we had only a 3 cluster solution in that case. So these are all ways in which you can experiment with these things. So let's go back to doing that and doing the PCA the proper way, getting this. So this is what we get from the principal component analysis. So do we have clusters? The answer is yes, but whether we have 2, 3, or 4 is your decision to make. But once again, you can use orange And its algorithms are not unique to Orange, by the way. These are well-established algorithms. We can use another algorithm to actually help us determine how many clusters there are. Incidentally, next year, we'll also be using Orange for machine learning. I think you've all heard of machine learning. It's the big thing just now in AI. And I'm going to use it with you in plant systematics because I'd like you to be familiar with it. Plant systematics will just be the application of AI and data mining. But this is something for your present and your future. Remember, in a few years' time, if you can't use ChatGPT, if you can't use data mining, you are as good as illiterate. Remember that. So things change quickly. Let's keep up to date with things, please. Okay. By the way, Floor, do you mind if I ask? I know that I've probably asked this before, but I've asked it to many people. Have you done anything with AI or ChatGPT or machine learning in your home university, or is it new over here?
No, I haven't used it a lot back home.
Okay, all right. I'm just asking because for all I know, you might be doing things that you've already sped through before. Okay, all right. So I'm going to use another method, which is called k-means. Now, K is actually coming from the German for cluster. And in cluster analysis, we get a suggestion for a number of clusters, but in k-means, we're asking the data analysis algorithm to divide our data into a number of clusters mathematically. So we're saying we want 3 groups. We want 4 groups. And actually, this is something that we use quite a lot in image analysis when we're recoloring images or even doing vegetation maps. For instance, one of our, well, you know, Leanne, the RSO, the lab demonstrator, for her master's, she did plenty of this. She had maps of her study site. Each pixel had, you know, a color based on the vegetation in it, and then she simply grouped them all into different kinds of green, which mean different kinds of plants, and that is done using machine learning, using k-means. So I'm going to get the k-means algorithm, which is somewhere here. It should be under unsupervised learning. Yeah, here it is. I'm putting it here and getting the data into it. What does it show me? Now, it's trying out various groups of clusters, and for each grouping, it's giving a score. And over here, it's showing me that the 2-cluster solution, at least mathematically, makes most sense. Because after all, what is a cluster? A cluster is simply a group of entities, in this case releves, that have more in common with each other than they do with members of other clusters. So, in a sense, let's take our own groups, fieldwork groups. The cluster containing Julia and Diana and Clint and Nathaniel has much more in common with each other than they have with some other random cluster. Why? Because 3 of them come from Gozo and 1 of them comes from, well, now from Einsilem. So they all come from Gozo. Therefore, they have that, you know, I come from Gozo feature in common with each other, making them more similar to each other, their members, than they are to, I don't know, to Crystal and Neve and whoever is in their group, Valeria. So a cluster, a group, is simply defined as a number of entities that have low variance amongst themselves, that are similar to each other, certainly more similar to each other than they are similar to outsiders outside the group. Do you get what I mean with that, please? Okay. That also explains your friendships. You form friendships and alliances with people who are similar to you. So I don't know, I mean, even if you look at the groups that we have here, probably there are many common factors that led you to deciding to be in the same group. Neve and Crystal have been together in every single group since first year. There are reasons for that. It's not because Crystal has a chain on which she keeps Neve or vice versa or something like that. I'm glad Neve isn't showing us her face just now because I can imagine she's swearing in Neve-ish. And
I'm laughing.
are you laughing? All right, okay, that's great. I was half expecting a spell to come to the screen and hit Ben by mistake. No, anyway. So that is it. So according to k-means, the best solution is actually the two cluster solution. Can you see that, please? And that gives us the greatest difference between these groups. If we go for a 3-cluster solution, it's better than a 4-cluster solution. Can you see the silhouette over here? 0.282, but not very different. So the difference mathematically between the 3-cluster and 4-cluster solution is not that great. There's also a 5-cluster solution, which is now pushing it somewhat. And so on and so forth. But from my part, I would go, mathematically, it's a 2-cluster solution. But does mathematically match what you see biologically? So you might decide that a 3-cluster solution makes more sense, or a 4-cluster solution gives you more information. There's nothing much to choose between the 3 and 4-cluster solution. They're practically the same. So if you choose the 3, you might as well choose the 4, depending on what we get. But don't get too many clusters because then you lose information. It's not very useful then. Are we clear about that, please? How to use k-means, etc. So what do we do next? What we do next is something like this. We go back to Google Earth and I'm sorry, moving things around because your little thumbnails showing all of you are getting in the way of Google Earth. Fun fact, in exactly 12 months' time, you'll have finished your course and your exams. Not sure if that's going to lead to mass hysteria and lots of crying, but unfortunately, you've only got 12 more months of this. And then there's no point in going on with life anymore. I mean, well, what point is there to life if you can't come to uni and do assignments, etc.? Now, anyway, so let's start off from here. I'm also opening somewhere else the data file that I've got. Yeah, now I've got to find some way of getting at least 3 windows on my screen. Does anyone remember how to get 3 windows at the same time on your screen, please? Okay, so
Usually I hold the minimize button. When you scroll over it, and it gives you the option.
Okay, here it says maximize, but okay, I get what you mean. So, all right, okay, that's great. Thank you, Crystal. That was you, wasn't it?
Yes, yes.
Because I was only getting a voice, the window wasn't open. All right.
No problem.
Okay, we're still just 10 replies over there. No. So, yeah, thank you, Crystal. Great job. That's just to make you feel guilty. No. But also because I couldn't get it out of the way. Now, so let's start off. I had to get Google Earth in it, not. Yeah, that's more like it. So let's start off from here. Cluster 1, C1, we've got relevés 1, 2, 3, 4, 5, 6, 7, 8. So let's, okay, relevés 1, 2, 3, 4, 5, 6, 7, and 6 are in site 1, site A, sorry, so that's over here. Site A is the red one. And 7 and 8 are in site B. So we have one group containing all the site A relevés plus 2 from here. The second cluster contains all the others. So if we now had to draw a vegetation map, what we'll have essentially, if we have to do it with common sense, this is one cluster and the rest are another cluster. Do you get that, please? Okay, so if we look at the two cluster solution, cluster 1 contains all the relevance in site A plus another 2 from here. And cluster 2 contains all except 2 of the relevance from here, all the relevance from here, and the only relevant from here. So essentially, if we had to simplify it with a two cluster solution, our vegetation map would be very simple. This is one zone, and that, including that, is a different zone. Is this clear, please? Okay. If we have a three cluster solution, so we still have this as one cluster, but then 9, 10, 11, 12, 13, 14, 9, 10, 11, 12, 13, 14, which are in site C over here, form a different cluster. And 15, 16, 20, 19, 17, 18 form yet a different cluster. So with a three cluster solution, we've got this is one area. Half of that is one area, and that is a different area. So more or less, the area that we were looking at, and you can see it from the pictures itself, is very different from the rest of the Dweira area, as you can see. So all of this would be one zone on your vegetation map, except where you've got the wetland over here. This would be another zone, and perhaps that another zone. But yeah, with a four cluster solution then, this is now split up into two, which might or might not make sense. I think it doesn't. So what I would go for is probably a three cluster solution or a two cluster solution. So if we're drawing a vegetation map, you need the site from the data file, by the way. So if we're drawing a vegetation map, we could draw it something like this. Now, I'm drawing it in Google Earth because I'm doing something else in QGIS just now, and I don't want to lose that. So let's see this. You're going to be drawing this in QGIS. It gives you some practice. But I'm going to use it in Google Earth just to hurry things up. So The final analysis was this. We have a two-cluster solution that is mathematically optimal. So on Google Earth Pro, I go on Add Polygon. Polygon is a shape. And I'm drawing around the inland sea and drawing the first, going around the car park. And drawing the first of our two phytocoenoses. Drawing past the wetland because that is not part of it. And we've got that. Let's call that cluster 1, or rather community 1 or something, or phytocoenosis 1. The color can remain as it is, so that's it. The second phytocoenosis, according to our two-cluster solution, so the second vegetation zone, would have been this. So I'm adding another polygon over here, starting off from here, including the cliffs, because some of those relieves came from the cliff. Ignoring the car park, naturally. And drawing the line over here. It's actually a bit larger than the site which I had in mind, but this is just for demonstration. Naturally, when you're doing your own work, make it a bit neater than mine. I'm doing this in a hurry. You're going to have weeks to do this. Yeah. Let's call that phytocoenosis 2. Give it a different color. And the area of the wetland is also part of phytocoenosis 2. I'm going to draw its own polygon over here. And call it phytocoenosis 2. As well. So that is our vegetation map of the Dweira area. And that is with a two-cluster solution. If we had a three-cluster solution, we might have to draw another polygon over here. It was roughly somewhere up to here. We've got helichrysum. So phyto Phytocoenosis 2 and another one as phytocoenosis 3 over here. Something like that. So it all depends on the solution that you get mathematically on how to draw this. By the way, we're using the term phytocoenoses instead of community, because the term community implies a lot of assumptions. A community is a group of populations that are interacting with each other. Over here, we've got no empirical evidence that the populations of plants are interacting with each other. I'm not saying they're not, I'm just saying we have no evidence. So we simply use the term phytocoenoses, which is more accurate in that regard. And this is how you get this. So mathematically, the optimal solution would have been this one, but you might decide that biologically and ecologically, this would be a better solution. So it's up to you to see what reflects reality. Remember that the mathematics behind it is only as good as the data that you've given it. And if the data that you've given it is crap, because one of your plants was the blue whale, because you don't recognize plants, then you're going to get very strange results. So your final output as a group should be the vegetation map that you've got here with a justification of how you got those groups over there. Every single group will be using the same data set. But for all I know, different groups will be doing the cutoff points in different places, because although you're going to get exactly the same results, the interpretation of those results can be different, because one of you might decide that a 2-cluster solution is great, others might want a 3 or 4 cluster solution, because that reflects reality more correctly. Are we okay with that, please? Okay, before we continue, Diana, given that you're keen on horses, can you name 2 film horses, or, well, 3 horses that have appeared in film or television? Come on.
No.
Okay, can anyone name 3 horses that have appeared in film or television?
I don't know. I haven't watched the film in Madonna of Scam.
Madonna ma nafx kemm is a long time, Floor. That's consistent for saying it's a heck of a long time.
Prof.
Yes?
I gotta leave, Tom.
All right, I'll give you the answer before you leave, because otherwise you're going to spend the rest of your life all over summer. No, one of them is Black Beauty, who you've heard of, and the other is Furia. It used to be in Italian as Furia Cavallo dell'Ouest. The other one is Shadowfax. Who rides Shadowfax? Gandalf. Lord of the
Never
Rings.
heard of it, Prof.
Okay, great. All right. Next time I'll stick to Mickey Mouse references. Thank you, Diana. Okay, you've got your meeting soon, don't you?
Does your offer still apply if biomed is locked?
Yes, of course, by all means. After making you sweat a bit, but yeah, of course I'll open. All right. Hang on, how are you coming from Gozo in time for the meeting?
Le, jim Malta.
Hey, Malta, all right, okay, great. Julia, anti wkoll jew qiegħda xewqija.
Xewqi għada.
All right, okay. Anyway, naħseb Clint ukoll u xek. U Nathaniel Millu ma jinsilem. So, okay, Diana, you can go. I think you've got the idea behind the assignment, don't you?
Thank you, Prof.
If there's any difficulties, just copy from Julia then. It's fine. Everyone does that anyway. So, okay. So, does anyone have any queries about this, please? We did that horses thing just in time. I didn't realize she was leaving. Now, so that is your assignment. By the way, can all of you see a mysterious, bright, shining white light behind Ben? I'm trying to figure out whether that's an alien from space, whether it's your soul shining up, or whether it's God saying hello or something.
I mean, it's been there for a long time, but so I don't really know.
Okay, all right, okay. Well, you've got that lovely shining light there. Makes you feel all mysterious. Now, so are we all clear about how the assignment will work, please? Okay. So what we're going to do is each group has to create a vegetation map. Now, let me anticipate one of the questions. Many of you will come writing and say, can we use Google Earth instead of QGIS? The answer is, of course, you can, because Google Earth has its own GIS facilities. But then you'll have learned nothing about QGIS. And please, one of the main objectives is that you learn something about QGIS. So even if it takes you a whole day to do that, please go ahead. Ben, you can ask Nicole, because I think I assigned her learning QGIS for the next 2 weeks. So she
Yes,
can.
I've been hearing the struggles of it, yes.
Sorry?
I've been hearing about the struggles.
Yeah, okay. Well, you could share the struggles and use it for your assignments over here, helping Flor and Marianne and whoever else in the process. Okay, does anyone have any questions, please? Does anyone have any questions about what we've just done, said, looked at, etc.? Okay, so I'm going to leave it to you to decide on a deadline. Katya, would you communicate that to me, please? But, you know, the latest, realistically, the latest I can do that is the 12th of July, because by the 15th of July, I have to hand in the results. Is that clear? And I would need at least a weekend to correct these. I'll also be putting up some grading guidance on the VLE, so you might wish to wait for that before you actually write up the final report. I hope to do that today or tomorrow. But in the meantime, the groups start working, get to grips with QGIS and Orange and whatnot, so that you'll have the results that you need. I'll also be sending you the data file that I've used. You're all on the Google chat that we use for our class, aren't you? So I can send it there, and that would be far simpler than using the VLE in that case. Okay. Right, any questions, anyone, please?
Will the recording also be available?
Yes. Now, that is why it's been recorded, Crystal. So it normally takes a few hours for the recording to be made available to me by Zoom. As soon as it is, I'll post it on the VLE and also on the YouTube channel that we use for these tutorials. So that way I'll have a few more views and followers. So far I've got, I think 8 subscribers, which is 8 more than I expected. But somebody told me I need about 1,000 to start making money from it. So I don't know. We're still quite some way away. All right. So yes, Crystal, it will be, and I'll be notifying you as soon as it is. All right. Okay.
Thank you.
Leanne, by the way, did you initialize your access card?
Yes, Prof, I did.
And you didn't need to sync to it to initialize it?
Oh, surprisingly not.
No, of course, yours was Simsalabim. I had told somebody else I had to sync to it. Okay. So sorry about that. Sorry, you're getting flashbacks. Yeah. Anyway, we'll stop here today in that case. Thank you. Flor, I'm not sure if we'll be seeing you again. I somehow don't think so.
No, definitely not physically, I suppose.
Yeah. Well, in that case, thank you so much for joining us this year. You fitted in really well. It's been a pleasure having you in our class. And okay, although you probably feel that you can't wait to go back because you're fed up of us. However, it's been great having you with us. Thank you
Thank
so
you.
much.
Thank you for
all of
having me.
And it was a pleasure. Thank you, all of you. Good luck with the rest of your assignments. And, you know, after that, it's not even BIO3060 in September. It's 3rd year and final year in the last week of September. Okay. That's in 3 months from now, 13 weeks. So have a good, well, I'll be seeing those of you who are doing their dissertation with me. The rest of you, if you need anything, please, I'll always do my best to help. Okay, thank you all of you. Have a great day, and thank you for joining today. Bye-bye.
Thank you.
Bye, thank you.
Thank you. Bye.